presentation, analysis of operational factors affecting the serviceability of seaport hoisting and transporting equipment. There are two teams of co-authors, one from Karpenko Physico-Mechanical Institute, another one from Odessa National Maritime University, both from Ukraine. Overview of the presentation. Introduction. Role of cycle loading in operational loss of serviceability of hoisting and transporting equipment. Role of corrosion environment in operational loss of serviceability of hoisting and transporting equipment. And concluding. Introduction. Hoisting and transporting equipment is an important component of seaport infrastructure. It should meet appropriate requirements for the mechanical properties of the metal, which ensure their serviceability during a planned long-term operation under combined action of cyclic operational stresses and corrosive marine environments. It should be taken into account that the mechanical properties of load-bearing structures of handling equipment are subjected to operational degradation. Its peculiarity consists in a sharp decrease in the resistance of brittle fracture, and this increases the risk of abrupt rupture of metal structures, including hoisting and transporting equipment, as is shown on this slide. In this paper, the manifestation of two important factors in the operational degradation of carbon steels, namely cycle loading and marine atmosphere, have been analyzed. Role of cycle loading in operational loss of serviceability of hoisting and transporting equipment. The stress ranges of certain units of the portal crane, so-called, operated for 33 years, had been analyzed. The measurements were done on the surface of the crane under conditions that corresponded to its normal operation using the strain gauge method. This made it possible to evaluate cyclic loading, stress, and most importantly, the difference between in their levels for the test crane units. As expected, the value of cyclic stresses to which the crane components were subjected contributed significantly to the intensity of degradation process in them. A comparative assessment of in-service stresses and the corresponding resistance to brittle fracture for each unit is presented in this table. A relationship between the obtained values of stress range and impact toughness has been established. The higher the stress level, the lower the resistance to brittle fracture. In addition, it was shown that delamination along the rolling direction accompanies the drop in impact toughness. This results in different KCV values for specimens cut longitudinally and transversally to the rolling direction. A big difference was revealed between impact strengths of specimens cut in different directions concerning a rolling direction. Impact strength level of transversal specimen was essentially lower in comparison with longitudinal specimens. And this difference was more significant for more stressed steel, that means more degraded state. Another peculiarity was revealed. The ratio of impact strength for differently oriented specimens is different for when considering thick and thin sheets of the stress in structural specimens. Role of corrosion environment in operational loss of serviceability of hoisting and transporting equipment. One of the consequences of the operational degradation of port metal structures is the intensification of corrosion process confirmed by electrochemical studies. The long-term operated steel corrodes faster than as received or normalized one. This means that the current technical state of a metal under operation should be also taken into account when prediction corrosion losses and metal thinning. It in the turn depends on the level of operational stresses. In other words, a high stress level leads to more intensive degradation of the metal that in turn causes corrosion acceleration. Here you can see a relationship between the resistance to brittle fracture and KCV and corrosion resistance for the steel taken from various units of the operated crane. And impact toughness is used as an indicator of its operational degradation, and polarization resistance is a measure of its corrosivity. Despite a significant scatter of the experimental data, a trend to the corrosion resistance loss with the drop of resistance to brittle fracture is quite evident. A high corrosion rate of the metal in the marine environment with hydrogenation capability implies the intensification of degradation process, especially in rolled steel susceptibility to hydrogen embrittlement. Based on this, it is suggested using such a relationship for elaborating a non-destructive method to assess the current metal state. And finally, remarks. Convenient approaches are unsuitable for substantially the safe excessive operation of steel structure of seaport, hoisting, and transporting equipment, since they do not take into account the degradation of the mechanical properties of metal, first of all, characteristic of brittle fracture resistance in the course of its operation. The crucial factors in the operational loss of serviceability of handling metal structures, namely operational stresses and ambient environment, are considered. Firstly, intensive operational cyclic loading significantly varies for different structures units, thus leading to different levels of their operational degradation. And secondly, the marine environment affects the serviceability of seaport structure not only because of the risk of corrosion damage, but having hydrogenation capability intensifies the operational degradation of the metal and, on the other hand, facilitates fatigue cracks growth by the hydrogen embrittlement mechanism. Thank you for your attention.